All right, what does a determinant determine? What does a determinant determine? I'm sorry, what? I thought you were asking me. It determines if an inverse of a matrix exists. If the determinant equals 0, the inverse is undefined or not possible. What is the other stipulation of finding a determinant? We talked about it yesterday. Do you remember? There's one other stipulation. To find an inverse, what's the matrix have to look like? Good. Matrix must be square to find the determinant. And so if I were to give you one and say find the determinant and it was a 3 by 2, best kind to get because you don't have to do any work. You can just say, I'm not going to do this. It's not square.
Will there ever be like imaginary inverse?
I've never done one like that. I'm not going to say there's none ever out there, but not that I've ever done. Application of area using matrices. Thank you, just lay right there. All right, so when you look at the formula, when you get the determinant, remember when these look like straight sticks, that means find the determinant, and it's not going to have any words. It's just going to have plus or minus 1/2. Instead of the little brackets, which represent matrices, these are straight sticks, straight lines that make a matrix. And without any words, you know that that means find the determinant. There's something called the Bermuda Triangle, which we're going to use as an application practice question. And we're going to find the area of approximately what that would be. Anybody need more time on this? Everybody good? All right, then. We are going to start with the point 0, 0. And that would be located at Miami. And then we have Bermuda here. And that ordered pair, if you laid an ordered pair down on a map and used it like a grid, that's Bermuda. Then we're going to use Puerto Rico down here. And it's located at 900, negative 518. So even though it looks somewhat like it would be an isosceles triangle, it's not, because this one goes right 938 and this one goes right 900. It's just hard to differentiate them when there's 9 marks between here and here to get to 900. Now, if we use the matrices formula, we would say area equals plus or minus 1/2. I'm going to start with the point 0, 0 as my x1, y1. Then I'm going to go to Bermuda, going clockwise, 938, 454, my placeholder's 1. Then I'm going to go to Puerto Rico, 900 negative 518, placeholder 1. What is the next step we did yesterday when we had a 3 by 3? We had to find the determinant. Anybody remember? Right, we have to rewrite the first two columns, perfect. Because otherwise we don't have the diagonals that we need. So when I start on the down, it's kind of nice on the first two. Why? Aren't they both 0? Then we have the third one to be 928, or 938. 938 times negative 518, which gave us negative 485,884, which is negative 485,884 when I do my third down diagonal. Now, what nice thing is going to happen on the up diagonals? Well, the second two are going to be nice and go away. So I have a plus 0, plus 0. My first one, however, I have to do 900 times 454 to get 408,600. Now, what you have to remember is what's sitting out here waiting for us to get done. Right, we got to take plus or minus a half of it. All right, good. So we have negative 485,884 minus, what's wrong, Wes?
No, I'm just trying.
All right, so I get a big number, negative 894,484, and I need half of that. So I'm going to get two answers. I'm going to get negative 447,242, and I'm going to also get positive 447,242. And let me look at the original problem. It was originally given in miles, so this area will be miles squared. Now, which one of these answers do I throw out? How come? We do not have real life negative area that I know of. Now, I told you yesterday that we were just going to hold off and work on this today so that you just practiced finding the determinant yesterday. That was the goal. So today, we are going to continue in lesson 3.7, page 208. You're going to do 20 through 26, 22 through 26. You're going to find the area, and then you're going to do two application problems, a 40 and a 41. So each of the questions below are going to require you to use this formula in lesson 3.7, page 208, 22 through 26, 40 and 41.